Kepler 452b promised us a new Earth, but gave us only silence. Titan tempted us with alien oceans, yet left us with more questions than answers. Now, a new world has entered the stage, K2-18b, the first exoplanet where water vapor has been detected in its atmosphere, and maybe more. Are we ready to meet a world that could change everything we know about life?
Picture this. You're sitting at home, scrolling through your phone, when suddenly every news outlet on Earth starts broadcasting the same incredible story. The James Webb Space Telescope has just made a discovery that could change everything we thought we knew about life in the universe. Webb's infrared sensors can analyze the atmospheres of distant worlds by studying starlight as it passes through them. And in September 2023, it detected something extraordinary in the atmosphere of K2-18b. Not just water vapor, but also traces of dimethyl sulfide, a gas that on Earth is only produced by living organisms. Scientists around the world held their breath. Could this be our first detection of alien life? Now, imagine you're part of the first mission to visit this mysterious world, 124 light-years away in the constellation Leo. As your spacecraft approaches K2-18b, you're immediately struck by how different this system feels from our violent journey to Kepler 452b. Instead of an aging, furious star, K2-18 is a calm red dwarf, smaller and cooler than our Sun, but destined to burn steadily for trillions of years. Your landing pod descends through K2-18b's thick atmosphere, and the first thing you notice is the pressure. It's denser than Earth's air, but not crushingly so like the hellish atmosphere we encountered on Kepler 452b. There, the atmosphere was a furnace of death. Here, as you step onto the surface, you realize you're breathing filtered air that contains actual water molecules, the same compound that makes life possible on Earth. The gravity pulls at you, about 2.3 times stronger than Earth's, the same crushing force we felt on Kepler 452b. But somehow in this context, it feels less like a death sentence and more like the embrace of a world that might actually be substantial enough to hold onto its precious atmosphere and water.
As you look up at K2-18b's sky, you witness something that no human has ever seen before: clouds made of actual water vapor hanging in an alien atmosphere. Remember our journey to Titan, where we marveled at methane rain falling from hydrocarbon clouds? This is the opposite extreme: real H2O condensing and potentially falling as genuine rain on an alien world. The temperature here ranges from a bitter -73 degrees Celsius to a surprisingly mild 47 degrees Celsius, depending on where you are on the planet's surface. It's cold, certainly colder than a tropical beach on Earth, but it's not the instant death freeze of space or the flesh-melting heat we encountered on Kepler 452b. With the right protective gear, a human could potentially survive these temperatures. You hold out your gloved hand and feel something incredible: actual water droplets condensing on your suit from the humid atmosphere. The air around you is thick with hydrogen gas, making everything feel slightly surreal, like you're breathing through a very light fog. But mixed in with that hydrogen are precious water molecules that your instruments are detecting in concentrations that make your scientific heart race. The atmospheric composition is unlike anything in our solar system. It's primarily hydrogen, like a gas giant, but with significant amounts of water vapor and possibly methane. Unlike the pure poison we breathed through our filters on Kepler 452b, or the exotic methane cocktail of Titan's atmosphere, this is an atmosphere that contains the most fundamental ingredient for life as we know it.
As you explore this mysterious world, you quickly realize that K2-18b presents you with one of the most intriguing puzzles in the cosmos. Is there solid ground beneath your feet, or are you standing on some kind of floating platform in a massive gas giant's upper atmosphere? Your instruments give conflicting readings. With a mass 8.6 times greater than Earth, this world could be a super-Earth with a rocky surface hidden beneath its thick, hydrogen-rich atmosphere. Imagine vast oceans of liquid water stretching beyond every horizon, kept warm by the greenhouse effect of that dense atmospheric blanket above. But there's another possibility that makes your head spin. K2-18b might be what scientists call a Hycean world, a hydrogen-rich mini-Neptune with no solid surface at all. In this scenario, you could be walking on floating continents of ice or dense gas platforms suspended in an atmosphere so thick it's almost liquid. Remember our journey to Titan, where we discovered that life might hide beneath kilometers of ice? Here on K2-18b, the situation could be even more extraordinary. If this world has floating biospheres in its upper atmosphere, life might exist in the warm, humid layers where temperature and pressure create perfect conditions for biology. No solid ground required. You deploy a probe downward through the atmosphere, hoping to solve the mystery. The readings show the atmosphere getting denser and warmer as it descends, but after kilometers of hydrogen and water vapor, the signal fades. Whether it hit an ocean, a solid surface, or simply got crushed by increasing pressure remains unknown. Standing here in the perpetual twilight of K2-18b's thick atmosphere, you realize that regardless of what lies beneath, you might be experiencing the first alien environment where Earth-like life could actually exist, either floating in these very clouds around you or swimming in hidden oceans far below.
Looking up through K2-18b's water-rich atmosphere, you see the soft, reddish glow of its parent star, K2-18, a red dwarf that couldn't be more different from the violent stellar furnace we encountered orbiting Kepler 452b. Remember how Kepler 452's aging star bombarded its planet with deadly radiation and slowly cooked away any chance of life? K2-18 tells a completely different story. This red dwarf is smaller, cooler, and incredibly stable. While our sun will burn out in about 5 billion years, stars like K2-18 can burn steadily for trillions of years, longer than the current age of the universe. But there's a catch that makes your exploration even more fascinating. K2-18b is tidally locked to its star, meaning one side always faces the sun, while the other remains in eternal night. You're standing on the boundary between these two worlds, the Terminator line, where day meets night in perpetual twilight. On the day side, temperatures might be warm enough for liquid water to exist openly. On the night side, everything would be frozen solid. But here, in this twilight zone where you're standing, conditions could be absolutely perfect for life. The eternal sunrise on the horizon provides just enough energy to keep water liquid, while the atmosphere redistributes heat to prevent the extreme temperature swings that would make life impossible. As you stand in this alien twilight, your instruments suddenly start registering readings that make your heart pound with excitement. The atmospheric sensors are detecting something extraordinary: trace amounts of dimethyl sulfide drifting through K2-18b's water-rich air. On Earth, this compound has only one known source: living organisms. Marine algae produce it, bacteria metabolize it, and it's considered one of the most reliable biosignatures we know. Finding it here, 124 light-years from home, could mean you're breathing air that has been touched by alien life. But as a scientist, you force yourself to remain cautious. Could there be non-biological processes that create dimethyl sulfide? The harsh truth is that we don't fully understand all the chemical reactions possible in such an exotic atmosphere. What seems like a smoking gun for life might just be unusual chemistry we've never encountered before. You take atmospheric samples, knowing that these small vials of K2-18b's air might contain the most important discovery in human history. Unlike our devastating experience on Kepler 452b, where every measurement brought only disappointment, or our journey to Titan, where we found exotic chemistry but no definitive signs of life, K2-18b is offering us something unprecedented, genuine hope backed by solid scientific evidence. The water vapor readings remain consistently high, confirming that this world has maintained its precious H2O for potentially billions of years. Combined with the stable energy from its red dwarf star and the possible presence of biosignatures, K2-18b represents our best candidate yet for finding life beyond Earth. But perhaps the most incredible part of this discovery is how close it is to us. At 124 light-years away, K2-18b is practically next door in cosmic terms. Future space telescopes will be able to study this world in unprecedented detail, potentially confirming whether those biosignatures represent our first contact with alien life.
As your exploration time draws to a close, you take one last look around this enigmatic world that has filled you with more hope than any planet you've visited. Unlike the crushing disappointment of Kepler 452b or the exotic but sterile beauty of Titan, K2-18b feels different. It feels alive with possibility. The soft red glow of the Terminator Zone, where you've spent these precious hours, seems to whisper of secrets just beyond our current understanding. Every breath of this water-rich atmosphere, every measurement of organic compounds, every reading from your instruments suggests that life might not just be possible here, it might actually exist. You walk slowly back toward your landing craft, taking careful steps across terrain that might harbor the first confirmed extraterrestrial ecosystem. Each footstep could be historic. Each atmospheric reading could be humanity's first glimpse of life beyond our solar system. Remember how we felt leaving Kepler 452b, crushed by the realization that our dreams of a second Earth had been shattered? Or how we departed Titan, amazed by its alien chemistry, but knowing that any life there would be utterly foreign to us? K2-18b offers something different. The tantalizing possibility that familiar, water-based life might exist in those clouds above you or in hidden oceans below. As you climb back into your spacecraft and begin the long journey home, you carry with you something more precious than any physical sample: genuine scientific hope. The data you've collected here might represent humanity's first steps toward answering the greatest question we've ever asked: are we alone? Your ship lifts off from K2-18b's surface, and as this mysterious world shrinks behind you, you realize that this might not be goodbye forever. This could be the first of many visits to humanity's most promising lead in the search for extraterrestrial life. In the near future, advanced telescopes might confirm what you suspected during your brief time here, that K2-18b is not just another exoplanet, but our first glimpse of a living world beyond Earth.
K2-18b isn't just another planet. It's a mirror, one that reflects what might be waiting out there, or within us. Could we truly recognize life if we saw it? Would we accept it if it looked nothing like us? As telescopes stare into the darkness, perhaps it's not the universe that needs answering, but ourselves. Leave your thoughts below, and don't forget to subscribe, because more journeys are coming. Journeys to worlds that may change everything we thought we knew about the universe.